Hello, good day. So this is okay. I'm Robbie from Nigeria. So this is my tax one on brain tumor segmentation using YOLO11 and SAM2 model. Currently on cargo, I ran the whole code on cargo using its GPU. So overview of this is the project is to detect brain tumors using YOLO object detection and SAM2 model, segment anything model for precise segmentation. Now the data set is gotten from Roboflow. The link is also in the code. And inference is performed on the test images for detailed analysis. So what I did first is from Autoanalytics, I first installed Autoanalytics. I got the YOLO11 model and the other libraries I'll be using. So when the first cell, okay, we have the API to the data set, workspace and the version. Then loading the model, the YOLO11 model, then I trained the model using the data set I obtained. So let me run the first cell. Now since this should be fast enough, since most of the requirements are already satisfied, so it shouldn't take long before the whole thing finishes. The F1 loss keeps reducing at least two each epoch keeps reducing. We have 0.8 here, we have 0.65, 0.648. Okay, turn it up a bit here, 0.01. Okay, choose on the sixth one. On the ninth one, okay, 13th one. Now the data set gotten from Roboflow as since we're using a pre-trained model, it has the training set and its test sets there separately. So the link so what okay, yeah. Okay, the 16th one. And we are done training. So it gives you the total number of instances found, no tumor, glioma, for the instances and for the box, so on. So it saved the result from this is saved on this folder, result detect twin. You can access that from where is that? Should be somewhere. Okay. It should be here. I'm gonna refresh this here. Alright. So after training the model, next is to load the model. The model is found there, best.pt is found in weight. So that's the model we'll be using, the best one. So now to perform the object detection on an image, we give it the link, URL to that particular image. We give it to this and set save equals to save the image, then result to show. So once I run the cell, to detect, gave it a bounding box, meningioma 0.5% confidence, that is meningioma. That's for performing the object detection on an image. If you want to perform it on multiple images, just give it the URL to the entire directory, containing the entire images. Detection, okay. Running the second model. Then this is performed on the whole image. On the whole image, 191 images. Perform the same thing we did object to the one image. Performed everything on all images. 191 of them, and save equals 2. So it is done, and the result is saved in predict 2. So predict 1 is for just when I did the first image. Now this is for the whole directory that contains the whole images, saved in predict 2. So here is what I did here is I run a batched inference on a list of images. Then I saved it as result. Then processing the result to apply a bounding box on the output. So that output will be the input for the SAM2 model. So on this cell, you can see the various the shape, we have the shape to be more touch dot size 1,6. Then you have the xywh, and that is the coordinate for the bounding box, various coordinates for the bounding box. Right. Now that's all for the YOLO11 model. We are done with the object detection and we have performed the inference on it to get the bounding box. Now the output from the YOLO11 will be the input for the SAM2 model. So again, we load our YOLO11 model, then we run the batch inference on a list of model. What we did up here, we repeat the same thing down here. Let me run that. Then I load the SAM2 model. So now for resulting result, that is the result we got up there, the bounding boxes, right? Using this coordinate xy, result.boxes.xy equals boxes. Now these boxes will be given to the SAM model for the segmentation. Save equals 2 and device equals 0, right? So the result is saved in predict folder, right? So let's look at the output where output let me rephrase this. Okay, I should have the output here exactly. So this, let me rephrase this. Right, okay. So this YOLO, this had the two models, the SAM2 model and the YOLO11. Then the runs, the dataset is stored here. Yeah, then the runs, we have the detect, the segment, and the detect is for the YOLO11 and the segment is for the SAM2 model. So when we look at that, let's look at, so this, let's view the image, because okay, let me say download that and open file. Oh, so you can see, hold on, let me, so when I, okay, let me do this. Let me do this. Okay. Output runs, segment, predict. So this is the image, right? You can see the YOLO11 gave you the bounding box with the confidence of 0.95%. Then the segmentation, the blue segmentation around the tumor is done by the SAM2 model.